This is lesson 1.2, and in this lesson we're going to talk about sequences. So let's get started. A sequence is just an ordered list of numbers, as you can see on your screen. Each of these numbers in the list is called a term. So 2, 4, 6, 8, 10, 12, 2 and 4 and 6, each of these are terms. Notice at the end of this sequence is a ... which means this term or this sequence goes on forever. Same with the second example, 1, -3, 5, -7, 9, -11. This is a set or list of terms, and it goes on forever. This is known as a sequence. Now, sequences have their own notation. So when you're talking about sequences, the first term is always denoted as U sub 1 or U1. That's U with a little subscript of 1. Makes sense then if this first term is U1 that the second term would be U2. And the third term would be U3, U4, and so on, all the way up to the nth term. The n just means any number of term in the sequence. So U to the n denotes the nth term. That's not necessarily the end of the term, especially if the sequence goes on forever. It's just the nth term. So if this is the nth term, then the one right before it would be un minus 1. It's just the one right before it. So let's look at an example. This is a sequence, and it's laid out in a diagram. So the first diagram has one little circle, the second diagram has 3 little circles, the third diagram has 5 little circles. And you're smart, you can probably see the pattern already. 1 plus 2 more is 3. 3 plus 2 more is 5. So you could write this in terms of a sequence by saying the first term is 1. The second term is 3, and the third term is 5. Now looking at that pattern, you can probably figure out that the fourth term is going to be 7. And how did I get that? Just add 2 more. Now this pattern is what's known as a recursive pattern because you can figure out the next term in this sequence by knowing the one previous. So I can figure out the third term in this sequence by knowing what the second term is and adding 2. And you can write that out in this way. Un, that's the nth term of this sequence, is always going to be the one right before it, un minus 1, plus 2. Okay. Now, the second example is asking you to graph. For now, we're going to not graph a whole bunch because it's a lot easier on a graphing calculator and not everybody has one of those. But you could graph a sequence like this one. And notice it's the same pattern as the last example. You can graph a sequence by making a list of ordered pairs. Remember, an ordered pair is an x and a y. It's a domain and a range. So the domain for a sequence would just be the term number, and the range would be the actual term. So for this example, the domain would be the first term, the second term, the third term, the fourth term, and so on. And the range would be whatever these numbers are. 1, 3, 5, 7, 9, and so on. So you can make a list of ordered pairs. The first term is 1. That's 1, 1. The second term is 3. That's an ordered pair, 2, 3. The third term is 5. That's another ordered pair, 3, 5. And then you just graph those points on a graph. Okay, so I mentioned recursive sequences. A recursive sequence is just defined, a sequence is defined as recursive if you know the first term and there's a method for finding every term after that by using the one that precedes it. in this example, you're given a sequence with 1, 2, 3, 4, 5 of the terms are given. So you could write out the first term is -7. I know the first term, that's part of finding a recursive sequence. The second term is -4. The third term is -1. Now, if you have 3 terms, you can find the pattern pretty quickly. And the pattern is that if you have -7 and the second term is -4, the pattern is that you add 3. If the second term is -4 and the third term is -1, add 3. So you can find this sequence recursively by saying any term in this sequence is equal to the previous term plus 3. Now in this example, we're going to look at a sequence that doesn't have repeated addition, but is repeated multiplication. And sometimes it makes more sense to use a different notation, an alternate sequence notation. So instead of starting at the first term as U1, we're going to use U0. And U0 is going to represent the initial height of a ball. So this problem says the ball is dropped from a height of 9 feet. So that's the initial height. It hits the ground and bounces to a height of 6 feet. So the next term in the sequence is going to be 6 feet. And it turns out that 9 times 2/3 is 6. So this ball continues to bounce, and each time it bounces back up, it rises to a height that's 2/3 of the previous bounce. So the next term in the sequence would be 2/3 of 6, which is 4, and so on. And you could write a recursive formula for this sequence, same way you would the other sequences. Any term in the sequence is going to be the previous term times 2/3. Or it makes more sense to write it in this way, 2/3 times the previous term. And again, this is the same as the sequences we've been looking at. It's just an alternate way to start the sequence. Instead of U1, we would start at U0. Alright, the last example we're going to look at for this video is about a chord in a circle. And I'll just read it to you. A chord is a line segment joining 2 points of a circle. The following diagram illustrates a maximum number of regions that can be formed by 1, 2, 3, and 4 chords, where the regions aren't required to have equal areas. So if you take a circle and you draw a chord across it, it takes that circle and creates 2 regions. Take the same circle and draw 2 chords across it, it creates a circle that has 4 regions. In the same way, 3 chords make 7 regions, 4 chords makes 11 regions. So, to figure out a recursive sequence for this diagram, you start by writing out each of the terms. The first term is 2, second term is 4, the third term is 7, and the fourth term is 11. Now, to get the second term, you would take the one previous to it, U1, and add something. 2 plus something is 4, you would add 2. To get the third term, you take the one previous to it, U2, and add something. To get from 4 to 7, you have to add 3. The fourth term, to get the fourth term, you'd have to use the third term, which is 7, and add something to it. 7 plus something equals 11. That something is 4. So the pattern for this recursive sequence is that you can find any term by taking the previous term and adding something to it. Well, it turns out that what you're adding to it, 2, 3, 4, those aren't constant, but they just happen to match the term number. 3 matches 3, 4 matches 4. So the way you write this recursive sequence is u n minus 1 plus whatever the term number is. Now, I don't know if you would have come up with that on your own, but it's good to see that a variety of different sequences that you can write in recursive form. And that's it.